Okay, hello again, PreCalc students. The first two videos were about graphing cosecant graphs. The first one was actually graphing it, and the second one was kind of going over what endpoints and midpoints and the quarter points are, Q1 and Q3. So this one now we're gonna have a couple videos here talking about solving and simplifying trig equations and expressions. Okay. So this one's going to be just on solving trig equations. So I'm going to give you a couple examples with homework at the end. So let's start off with something like this. Cosecant squared x minus 1 equals 0. Okay, well, I'm going to look at this and I'm going to say, the first thing I'm going to ask myself is, there's a couple ways to do this. I can first just start off doing an algebra. Cosecant squared x. I'm going to do plus 1. I'm going to move that plus 1. Go plus 1 here. So cosecant squared x equals 1. Next, I want to get rid of that square, so I'm actually going to square root both sides, and I'm going to be left with cosecant of x equals, now be careful, because the square root of 1 is plus or minus 1, so that's going to give me cosecant of x equals 1, cosecant of x equals negative 1, okay? And then now, you may be asking yourself, well, okay, I can figure this out now because all I have to do is ask myself, the cosecant of what will give me 1? The cosecant of what will give me negative 1? Okay, but we're going to do it algebraically. Algebraically, the way this is done is I'm going to divide by cosecant, which is the same as multiplying by inverse of cosecant. I'm going to divide by cosecant. So what I'm essentially finding here is I'm trying to find the cosecant of 1. I'm x is equal to inverse of negative 1. So I have to now find out what has a cosecant of 1. Okay, now before we do that, let's keep this in mind. Remember, cosecant is the reciprocal of sine. Okay, reciprocal of sine. So I want to find what has a cosecant of 1 of negative 1. Okay, that handy dandy 1, and I want to find the cosecant inverse of negative 1. Cosecant inverse of 1. So 1 over sine must be 1. Okay, let's look at our sine. Sine, remember, is the y value. So, up, right there. Over there, our sine is 1. So if I reciprocal 1, I'm also going to get 1. I just found it. Pi over 2. I'm going to get x pi over. What else I got here? Okay, I want sine to be 1. Well, the sine is negative 1. If I reciprocal negative 1, I'm still going to end up with negative 1. Not what I want. I want cosecant inverse 1. Okay, well, that's it for cosecant inverse 1. But I also am looking for the cosecant inverse of negative 1. So let's take negative 1. That means the sine has to be, sorry, sine has to be negative. Look in here, that's the only one. That's at pi over 2. Now, looks like we have two solutions here. Now, there's one thing I should have put here, which I haven't yet. What is the restriction? What are we just solving for everything? No. And the range from 0, I want all the solutions to be pi, essentially 0 to pi from 0 all the way back. If you notice, pi is not included. Okay, that's why it's got a. Why does it do that? Well, it's pretty simple because 0 is already the same as 2 pi. Okay, so if we're doing that, we'd be counting that rate, counting it twice, which we don't want to do. Now, going back to this, we have our two solutions. If I didn't have we'd be stopping there? Wouldn't I be able to keep on going? Because it doesn't stop at 2 pi. It can go to 3 pi, 4 pi, 5 pi, 6 pi. It can keep going. Okay? So for that reason, there would be infinite solutions if I actually did that restriction. Because you could just keep going. You can keep going and just go by this pattern and keep on getting more and more solutions. Okay? But you can do 5 pi over 2 and so on and so on. Okay? And it'll work. But for our purposes, know that you don't have infinite solutions. You just have a couple solutions. Okay, so now we're going to do a different example. And I'm actually going to go back to squared x minus 1 is the problem we just did. Okay, the problem we just did. But let's pretend someone did this instead of moving the one and doing all that. They did this. Now, we had x equals 1 pi over 2 pi. Put that in the back. Okay, one second. Okay, people are apparently doing lawn work at this time. So, anyway, so just keep that in the back burner, keep that in your mind for a second. We have cosecant squared x minus 1 equals 0. This looks familiar. This looks familiar to me. It looks like something part of our Pythagorean identities. And if we manipulate this Pythagorean identity by doing we end up getting cosecant squared x minus 1 is equal to cotangent squared x. Here's what I'm going to do. I'm going to replace this whole thing with cotangent squared x equals square root it, square root it. I'm going to be left with cotangent of x equals just 0. So remember, cotangent is not tangent is sine over cosine. So cotangent is cosine over sine. So the cosine over sine must equal to 0. Cosine over sine of x must equal to 0. Another way of doing this is just doing cotangent inverse. Algebraically, we do that. Divided by cotangent. That means the cotangent x equals cotangent inverse. So what cotangent, the cotangent of what is going to give us 0? Remember, cotangent is cosine over sine. Okay. So I need cosine over sine something to equal to 0. Let's see. Cosine over sine. Cosine over sine. 1 over 0, undefined. Cosine over sine. 0 over 1 is 0. Yes, it is. Pi over 2, we just found one. Cosine over sine. Cosine over sine, that's divided by 0, that's undefined. Cosine over sine, yeah, that's 0 over negative 1, which is 0. That's what? 3 pi over 2. Our two solutions are pi over 2, 3 pi over 2. Pi over 2, 3 pi over 2 from the first method. Okay? I am going to do a third problem now. I know it's getting a little bit heavy. We're at about 8.5 minutes already. So I'm going to do the third problem right now. All that. Okay. Last problem we're going to do is this. Stop right here. Take a look at it. I'm going to realize that these two terms have something in common. They do. Okay? They have something in common. So, i.e., factors. What do they have in common? Well, they definitely have a cosine of x, but they have cosine squared x. I mean, they both do. I can't do cube x because that one has it, this one doesn't. So I'm going to factor that out. Have cosine squared x times what gives me 2 cosine cubed x. That's going to be 2 cosine of x minus cosine squared x times negative 1 will give me negative cosine squared x. Perfect. Okay. So now we have to solve this out, but let's do the magic. ZPE, zero product property. Okay, I'm going to cover that. We'll cover that, set that equal to 0. Okay, so first let's do cosine. First let's cover this and do cosine squared x equals 0. And we will do 2 cosine of x minus 1. So I'm going to solve for both of these. One, I'm going to solve cosine squared x equals 0. And the other one, 2 cosine x minus 1 equals 0. Let's do this one first. Pretty easy. Square root. Cosine of x equals 0. Let's see. Cosine of what is going to give us 0? When is the cosine 0? Cosine is 0 here. 0. Cosine is also 0 at pi. So it's 0 and pi. X is equal to 0 and pi. Okay, but we're not done. That was just for cosine squared x equals 0. 0 product properties. Now we have to set this equal to 0. This one. 1 divided by 2 divided by 2 on left. Cosine of x equals half. Now you guys know the last step here would be to divide by cosine or multiply by cosine inverse and get the cosine inverse of that. I'm just kind of fast forwarding it, okay? So the cosine of what is half? Let's find that out. When is the cosine half? I want the cosine to be half. I got one there, pi over 6. Where else is the cosine half? Oh, I got one right there, pi over 6. And then it's negative half on those, so no. So pi over 6 and 5 pi over 6. Pi over 6. And there we have it. We now have 1, 2, 3, 4 solutions there. 4 solutions to this equation. Okay, now that we're done with that, I'm going to flip this over so you guys can get the homework problems. Okay, so for the cosecant graph, you guys had problems 1 and 2 cosecant graphs, with the phase shift, the amplitude, the general amplitude, all that. Okay, now we have problems 3 and 4, so you can continue on the piece of paper that you copied it on. 3 and 4, just 2 problems just like the ones I just did. Okay, guys? All right. There's going to be another couple videos coming up on simplifying shortly.